So I have no idea how this video is going to turn out. If it turns out good, we're gonna learn a lot. If it turns out bad, we're still gonna learn something. But at the end of the day, if all goes well, this 3D printer here, when it breaks, is gonna tell me how to fix itself. And that's gonna be pretty cool if it works. Because in today's video, we are going to install an AI on a 3D printer. And not the marketing AI spaghetti detective thing. I ask it a question and it gives me a response AI. So how do we do this? Well, first things first, what do I mean by AI? Large language models. I am nowhere near qualified to speak about the intricacies or how these things work. I'm a 3D printing YouTuber and I occasionally do cosplay stuff. Essentially, you take a whole bunch of data, you feed it into a computer, it uses its magic electrified sand to do science, and it compresses stuff, and eventually you can ask it a question, and based on what the data it has in its data set, it gives you a response, and it's pretty good at faking being a human, although it's not really an AI. And lately there's been a model called DeepSeek that's been released, and it's really putting a lot of pressure on the Western AIs, OpenAI, Llama, Meta, ChatGPT, all those, to kind of kick it into high gear, because apparently DeepSeek is very efficient. It was trained for a very low cost, and it didn't require all these massive servers that these other AIs were trained on. And the best thing is they do the training, and then you just take the model and you run it locally. And then what has happened is a lot of people have taken those models and they've refined them, and they're much smaller to run. On my desktop, I've been playing around with DeepSeek R1 32B, which pretty much maxes out my 3090, which has 24 gigs of VRAM, and it's using pretty much all of it. But there are models that are small, so small, they run on a Raspberry Pi. The same Raspberry Pi that is running Clipper in your 3D printer. So in pretty much every 3D printer that is running Clipper, you have a system on a chip running Linux, which is exactly what we need to install a large language model. So unfortunately though, we run into a hurdle right away, and that is simply the fact that you need a Raspberry Pi 4 or 5 for this to work. I'm not gonna speak on to all the custom SoCs that companies like Creality use in their 3D printers, because I have no experience with those. But most of my 3D printers that I build myself are using a Raspberry Pi as their brain. And unfortunately, a lot of them, including this guy here, use Raspberry Pi 3s. Because I bought a bunch of them years ago, before the shortage. They are cheap and they work good enough to run a 3D printer. You really don't need a Pi 4 or 5. So first things first, we gotta find a printer that has a Raspberry Pi 4 or 5 that we can install Ollama on. And we're gonna use my VZBot 330 that's on the ground here. It's big and it's heavy, so it's gonna stay on the ground, which is okay because we're gonna do all the work over SSH. So first things first, you're gonna wanna update everything on it. And the first thing you're gonna run is sudo apt update. Let that do its thing, and then you're gonna run sudo apt upgrade. If it's been a while, this may take a bit, but just let it do its thing. And then when that is done, we're gonna run sudo apt install curl. It should already be installed, but if it's not, it will install it. And then lastly, to install Ollama itself, we're just gonna run this one command here. All these commands will be linked in the video description, but this is basically a script that will install and set up Ollama without you really having to do anything else. And after you run that, it broke and it doesn't work. So it failed. Why is it failing? What's going on here? I thought this was supposed to work. Well, it turns out a little bit of a hiccup. That printer, the VZBot 330, is running a 32-bit version of Linux. And I guess from what I can tell, just doing some Google searching, no, I didn't ask an AI, the 32-bit version of Raspberry Pi OS that most people use as the basis for installing Clipper, it doesn't work with Ollama. The 64-bit version does, and I don't feel like reinstalling the firmware on one of my 3D printers just for something that may not even work. So instead, we're gonna use a test bench, and we are gonna use this. This is a Bigtree Tech Pad 5 that they sent me quite a while ago that I never actually did any projects with. But on this Bigtree Tech Pad 5, we have a Raspberry Pi CM4 with 2 gigs of RAM. So this will be enough for us to simulate the Raspberry Pi on a 3D printer. So we can go ahead and install the firmware on it, install Raspberry Pi OS, the 64-bit version, and then we can carry on where we left off with the installation. Okay, so we moved over to the desktop here so I can show you the screen and everything we have going forward here. But essentially, we've got the Big Tech Pad 5 here with the Raspberry Pi CM4 installed. I installed just the base 64-bit version of Raspberry Pi OS. We've gone ahead and installed Ollama as we were going before. But unlike the one in the VZBot 330, we actually have it installed. So we could see here, we have Ollama. And to install a model now, you do have multiple different choices of models from Ollama that you can go with. You can go with DeepSeek, Llama 3.1, Phi. There's a whole bunch here. I don't know the intricacies of all of them, but I do know some are slightly better than others at running on a Raspberry Pi. So we'll start here with Llama 3.2, the 1B version. So this is a refined version of the 3B, which is a refined version of Llama 3.2. So let's go ahead and install it. And to install the model is actually quite simple. It's just Ollama run Llama 3.2, 1B. And you just do that. It's gonna pull the model itself and it's gonna download it all. So we wait now. Yeah, it's gonna take a moment. I'll be back. And while it's doing that, you might as well take the time to enjoy a good refreshing drink of Gamer Sups. Use code Canuck, save 10% off your order, link in the video description. And it looks like we are just about done here. So after it downloads everything, it's gonna take a couple minutes here, moments to ingest it all and basically process or unpack. I actually have no idea what it's doing right here, but it's verifying the SHA-256 digest, whatever that means. And it looks like it's not gonna actually work. This model needs 2.1 gigs of system memory, and we only have a paltry 1.9. So what can we do? Well, I've actually gone ahead and installed some other models as well. So if we type Ollama list, it'll list all the models that we have currently installed on the system. And as you can see here, we have two other models. I've installed Tiny Llama. I've also installed DeepSeek R1 1.5B. So we'll start with Tiny Llama first. That is the smallest model that I have available here. So that's just simply Ollama run Tiny Llama. And then if you add this command here, -- verbose after, that essentially gives us a readout once it's done crunching the numbers and gives us a response that tells us how our Raspberry Pi is performing. My prints warp off the bed of my 3D printer. What may be causing this? It's thinking. The 3D printer is thinking. Sure, when printing with a 3D printer, the material you print on can cause the prints to warp or deform over time. This is due to the high temperature and pressure applied during the printing process. As the material dries and cools, it expands, causing the walls of the 3D object to be compressed and warped. The warping can occur in both horizontal and vertical directions and may cause the print to become misshapen or distorted. To prevent this from happening, you should ensure that your print bed is clean and free of debris or contaminants. If the bed is clogged with dirt or oils or other foreign matter, it can impede the print ability to extrude the desired material and cause warping. Well, that's not quite right. Additionally, make sure the printer itself is correctly calibrated and aligned for optimal printing results. Level your bed. If you still experience warped prints after cleaning your print bed, you may need to adjust or refit the printer or materials to ensure you are extruding correctly and evenly. If this doesn't resolve the issue, you may need to consult with a professional 3D printing service for assistance. So there you have it. According to Ollama, Tiny Llama, running on the 3D printer itself, or at least the Raspberry Pi that could be running a 3D printer, that is how you ensure that your prints don't warp. And that information is not quite right. There's some nuggets of good info in there, you know, make sure your bed's clean and whatnot, but the talking about pressure and stuff like it's hallucinating. It's not giving us the correct information. It's giving the information that, based on the data it has, what it thinks it should be saying. These aren't AI. They're the Turk. It's faking playing smart. So it will speak confidently about things it doesn't know because it will just kind of essentially assume based on data it has. It goes through a thought process where it thinks about the answer, or as close to these things are to thinking. And depending on that process, which you'll see in a moment here when I run another model, it can lead it down tangents. It can lead it to giving out the wrong info. So that's tiny llama, but DeepSeek's the current hotness, right? Let's see how DeepSeek runs. So we're gonna try DeepSeek on here, and we're gonna ask it the same question, but we're gonna see how DeepSeek responds. So let's pull that up here. /by ollama list ollama run DeepSeek R1 1.5b verbose. Now, when you load a new model, it does take a moment because essentially it's taking the entire model itself and loading it into RAM or VRAM, depending on your computer. So the bigger the model, the longer it's going to take to load. This is a bigger model. This is about twice the size of the tiny llama model that we were running earlier. So is it twice as smart? Not really. It doesn't really work that way, but it's twice the size. So we'll give it a moment here, and we are going to ask it the exact same question. My prints warp off the bed of my 3D printer. What may be causing this? And you're going to notice something really cool with DeepSeek here, and that is DeepSeek thinks before it speaks. So it's going to take longer here. As you can see, it's going much slower than the tiny llama model because there's more data here, and we have the same processor. So while we had more RAM and we could load a bigger model, now we're having to spend more time going through that model to generate our answer. But you can see here, this isn't the response. This is it thinking. And this is how it thinks. It's going through the motions here. Okay, so I'm trying to figure out why my prints are warping when I put them on the bed of my 3D printer. I remember that when you print, especially with filament-based printers like my Maker, I don't know where it's getting this info from, but that's the data set it pulled from. Sometimes the prints can shift or wobble. Let me think about what may cause it. So you can see here, it's already kind of hallucinating. So as you can see here though, it is thinking, it is working through the problem, and it's going much slower than the previous model. So I'll be nice to everyone here and I'll fast forward till we get to the end. Ooh, okay, and it's finally done. And if you're wondering about how much of the Raspberry Pi 4 2GB model it uses when it's doing this, it's pretty much using the whole thing. This thing is passively cooled with a heatsink on the back, but if you really want to be doing this a lot on a Raspberry Pi for whatever reason, you're probably going to want to actively cool that thing just to prevent it from throttling. But anyways, as you can see here, this is a much bigger response, and I'm not going to read it all. You can pause the screen if you want to read it, but this whole portion right here is it thinking. So this is how it gets to its answer. This is the thought process of how it got to its answer. And then this whole part right here is the answer itself. And you can see here, when your 3D prints wobble on the bed, it immediately kind of went down the wrong path. And you can see up here during the thinking part, its prints are warping. I remember when you print, especially with filament-based printers like my Maker, sometimes the prints can shift or wobble. So the thing is, remember, this is trained off data sets. Maybe this is pulling from an old forum post on the MakerBot forum. This is where this data is from. Who knows? We don't really have a way to find the source of this information. It doesn't give you a source at the end that you can reference to confirm that what you've been told is correct. Again, this is one of the downsides of relying on a large language model when it comes to hard fact type stuff. But the output it gave us was, filament types, test the filament you're using. Some materials react differently to heat, curing process, recurve your filament. Like it went down the wrong path. But again, this isn't really a 3D printing model. This is a generic model that has a bit of everything shoved under the hood. So what happens when we get an even bigger model? So unfortunately, we pretty much maxed out what this Raspberry Pi 4 can do, and I don't have a Raspberry Pi 5. So we're gonna go up a little bit to a NVIDIA 3090. So let's pull this up here. This is a NVIDIA 3090 running on my main desktop. So I'm connected to it over my home network. Hello. Let's wake it up here. Hello. So again, for some reason, the DeepSeek model really overthinks hellos, I've noticed. So it's going to think a lot about how to reply to hello, but then it'll reply hello. But this is DeepSeek R1 32B. So it's 32 billion data points versus the 1.5 that we were using previously. And this is running on a NVIDIA 3090 on my main desktop. It is using up pretty much the entire amount of RAM on my 3090 for it to go hello or hello. We're ready to tackle any automotive inferno you've got. What's burning your engine today? It's responding like that because you can kind of set it to act and respond in a certain way. And I told it to respond as you are a well-educated assistant in a workshop garage. You respond to questions in a snarky yet kind manner and occasionally use puns when it is funny. So I tried to, workshop garage because this is my workshop in my garage and it assumes I work on cars. So we get automotive puns. It's kind of funny. Anyway, so let's ask it the exact same question. So again, this is a much larger model. This model is like over 20 gigs of data loaded in VRAM, and this is being processed by a 3090. So exact same question. And as you can see, it's thinking much faster than the Raspberry Pi. And if I was running the model the Raspberry Pi was running, the 1.5, it would be very quick. Very, very quick. I think it's around like 100 tokens a second or something like that. It's much faster. Whereas this sits around 10 to 25 tokens a second, I believe, at this model. It'll say at the end, I think. But you can see here, if you were to take your time and pause the screen and read all this, this should seem a lot more realistic of an answer. So to address the warping issues on your 3D printer, consider the following organized approach. Use a raft or brim in your slicing software to improve adhesion. Apply a thin layer of glue stick or hairspray. Material and temperature settings. Ensure you're using the correct temperature for your filament. Slow down your print speeds on the first few layers to allow proper adhesion. Clean your build plate thoroughly. Consider switching to a different bed material. Like, not gonna lie, that stuff, a lot of this is good info. This is the kind of stuff you would get when you go to a generic 3D printing subreddit and most people respond, level your bed. This is akin to that. This is for the most part usable data. So what would be really cool and again, this is a 32B model. For reference, the full DeepSeek R1 model, the one that OpenAI and whatnot is causing all this hubbub about, the full DeepSeek R1 model is 671 billion. Is it billion? B is billion? Is it billion? Let me know in the comments below. Is the full 671B. You need over 400 gigs of VRAM, or just RAM, to load this model. It's insanely huge. So imagine if you were to take that massive model and you were to curate it. You were to take everything about that model that is just 3D printing related and very close adjacent information to 3D printing and just distill it down to a super hyper specific model that ships with your 3D printer on a Raspberry Pi. And then when little Timmy gets that printer for Christmas and he's like, it's the extruder is not extruding. The printer can go, hey, here are the things you can do when your printer is not extruding. Did you try ensuring that the filament has a nice cut tip on it? It's not mushed up. Is the gears jammed? Did you lock the extruder so it's actually properly gripping the filament? Do you need to adjust tension? Let's go through this. Oh, you just told me that the filament has grind marks on it. Oh, it might be too tight. Like, you could curate a model that can do a lot of that low-level Q&A stuff that keeps Discords busy. And again, unfortunately, because you can't ensure that it's 100% correct, it's never going to be a perfect solution, or at least not right now. But as we've seen, again, the Raspberry Pi in your computer and your 3D printer can speak with the right model as fast as you can read. We're getting there. I fear for our future. So I hope you enjoyed the video. This was a lot more fun than I thought it would be. I really wish I had gotten this installed on a functioning 3D printer that I had, but unfortunately all the printers I have were either hardware incompatible or I didn't want to go through the whole process of redoing the Linux install on a printer just for something that may not work. So we had to go with the test bench. But in the future, I do have printers that I will specifically set up so that I can install a large language model on them for who knows in the future. It'd be really cool to see somebody distill build down a small model that is trained specifically on 3D printing information to have running on a printer with a voice interface or something. That'd be really cool to see. And in fact, actually, just to give you an idea, this Bigtree Tech Pad 5 here, that's been running the model the whole time, it's completely wireless. It's on a battery, and yes, it's not connected to the internet. This is completely a standalone thing. You could put this, you know, for the Fallout people out there, I am working on some power armor, you can make a Pip-Boy with AI in it now if you really wanted to. From my understanding, you need quite a bit more hardware to generate a model than it is to infer a model, which I think that's the terminology for running it locally and just like how we've been doing it here. So I foresee in the future people that have the hardware resources and it's open source people. They do all kinds of cool stuff just because it's cool. I can see people making specific models with knowledges around certain use cases that can be used for a lot of these cool little scenarios such as this. I'm not a huge fan of AI in a lot of regards. There is so much AI slop out there. But I'm starting to believe if you dig through the AI slop, there are some good tools that can be made out of it. And I think we're on our way there. So I do want to give a shout out to Jeff Geerling. Been watching a lot of his videos lately. I've been watching him for years, but his fascination and obsession with Raspberry Pis and making them do stuff that I didn't think they can do has been a real good inspiration. So shout out Jeff, go subscribe to him if you're not. But yeah, I'm Taylor, the Canuck creator, and this turned out way better than I thought it would. And yeah, I'm totally gonna keep playing around with local models because they're fun. It's fun. Anyways, cheers.
Outro script. Thank you for watching our video on installing AI in your 3D printer. Integrating this cutting-edge technology is a game changer, empowering your creativity and enhancing your printing projects. Before you go, don't forget to subscribe for more innovative content and hit the